Hello and welcome back. So the next project I've decided to build is a car which can sense obstacles in front of it and turn out of the way so it doesn't crash into those obstacles. So I've often seen in the news many advancements in self-driving car technology, and I was really curious as to how that kind of stuff works. So I decided to try and build something similar to one myself. The way this car works is that it's able to use this ultrasonic sensor in a way similar to bats. The ultrasonic sensor sends out a sound wave and then listens to it. And then after doing so, it tells the motherboard whether there's an obstacle in front of it or not. And then the way I've programmed it is that the car's motors will turn to the right if it senses an obstacle in front of it, and if it doesn't sense an obstacle in front of it, it just keeps moving straight. So I've learned many things from this project. One of the biggest things I learned is how to program using the coding script C in the Arduino software. I was able to learn how the motherboard works and how it works with this ultrasonic sensor, and I've also learned how the ultrasonic sensor itself works. So to simplify how the ultrasonic sensor works, first it generates and sends out a sound wave, and if it hears the echo, it is able to decide, it is notified that there's an obstacle in its path. It will then measure the time taken between sending the wave and receiving the wave, and use that information to calculate the distance between the car and the obstacle in front of it. After doing so, it is able to, it tells the motherboard to turn to the right to avoid the obstacle in its path. Hello, I will be discussing the programming involved in building my self-driving car. For this, I have used the coding language called C, and I have used a software called Arduino in order to program this. In C, there are two parts to each program. There's void setup, which is over here, and void loop, which is over here. The purpose of void setup is to tell the motherboard which parts of the car it will need to use through the use of these pin values over here. These pin values correspond to specific pins on the motherboard. The purpose of void loop is to run commands and functions. In short, it is used to tell the motherboard what to do with the parts which was previously established in the void setup. It will also continue to run these functions, hence the loop part of void loop. Finally, here I have void sent. This is actually a function I have created specifically for this code, and its purpose is to tell the ultrasonic sensor what to do. First, it will tell it to send out a wave, and then it'll tell it to listen to the wave, which is over here. Then it will convert the time between sending out the wave and receiving the wave into values in centimeters. This function is then run in the void loop. As you can see here, it says sent1, which is where it begins running the function. After doing so, it will run an if function, which allows it to choose between two different options depending on an outcome from the sent1 function which I have created. So for example, if the ultrasonic sensor receives a value greater than 15, then the car will move forward, and if it will receive a value less than 15, the car will turn to the right. There are many real-world uses for echolocation and ultrasonic sensors. So for example, in the natural world, bats and dolphins use echolocation in order to visualize the world around them, which can help with them avoiding obstacles and catching food. Their ultrasonic sensors are also used in most cars to help with parking. The way this works is that a camera is attached to the back of the car, and this camera beeps whenever it senses an obstacle such as a pedestrian or a car or something else moving behind the car which is using it. This beep notifies the driver that there is an obstacle behind the car, and the driver is able to stop the car in order to stop from crashing into that obstacle. Ultrasonic sensors can also be used for self-driving cars. However, in that case, more ultrasonic sensors would be required in order to see more around the car rather than just straight ahead. As a result of this, they will be able to avoid any obstacles coming towards it from the sides, from the back, and from any angles other than the ones I have previously mentioned. I know this doesn't really look like a car, but if you could use your imagination, you could just visualize it as a car. Thank you.